this before class, but whatever. Okay. Okay, so hello everyone. Today we were going to talk about BP Farms, which is a project for optimization this term. And for a good presentation, you have to look the part. So I'm going to wake up my ลูกหลานชาวนา spirit and wear a hat so that I am in the spirit of a farmer. So first, because we're talking about BP Farms, we're going to meet the owner, Bill Pashley. This is actually not Bill. This is an artist rendition of what Bill might look like. But basically, this Bill Pashley person owns the farm and is also the only worker at the farm. Now, let's look at the problem that we're trying to solve. So let's talk about BP Farms a little bit. BP Farm is a 300-acre farm that grows either wheat, corn, oats, and soybeans. And then the table below is the information related to each of the crops. So it has the yield, which is in bushels per acre, the labor, which is in hours, the expenses in dollars, water, or the amount of water needed for each acre of land, which is in acre feet, and the price per bushel, which is for the yield. And we're not gonna ever come back to this slide, but if something needs to be referenced, it will be brought up. And then, because Bill is a needy little Bill, he has the following requirements. Number one is he has to grow at least 30,000 bushels of wheat and corn each, and he also doesn't want to grow more than 25,000 bushels of oats. And because he only has 25 grand in his wallet, so expenses cannot exceed that amount. And he's a very hard worker, so he's willing to work at most 12 hours of labor per day during the 150-day season. But at that point, he might as well just go work for Elon Musk or something. 12 hours, I mean, it's just same. Anyway, and in the end, because Bill is also very stingy, he's going to only use the water provided to him by the KAA, or the Kansas Agriculture Authority. And based on this, he wants to maximize his expected return or his profit. So next is the formulation of the LP problem. So for this, the best way to help Bill maximize his profit is by helping him allocate or decide how much land he should allocate for each of the crop. Specifically, we let Xi be the amount of land or acres per each type of crop, and the mapping is on the slides. And the unit for each variable is in acres. Let me turn off this because it's... And then the next thing is the objective function. Because we want to maximize Bill's profit, so we're going to take the yield, multiply it by the price. And this is going to be our expected income, and then we're going to pay the expenses per acre, and that's the expense. And then we multiply it by the amount of land allocated to each crop, and then we sum up this amount for every single crop. And then this is also not an integer problem because Bill can split up his land into like lesser than an acre and then grow accordingly. And in the end, we're going to end up with this objective function where the coefficients are the thing above, but already pre-computed based on the table that we have before. And to meet Bill's little requirements, we're going to come up with constraints as well. So the first one is because we're summing up the amount of land, it cannot exceed the farm size. And then there's also the minimum wheat production, minimum corn production, and maximum oats production. There's also the expenses and investments and labor. So labor is, because he's willing to work up to 12 hours in 150 days, so that's why it's 1,800, not something else. And the last thing is the water supply, which is also from the table. And obviously, because we can't have negative land, the precision variables have a non-negativity constraint. And putting everything together, we're going to end up with this full formulation. And we'll never come back to this ever again. And this is the answer report after we throw it to Excel, because I'm not going to solve it by hand, and I don't think anyone will. But this is not something that Bill can understand, or maybe he can. He might be a smart farmer, but we're going to translate it to English for Bill. So in conclusion, Bill is recommended to grow approximately 140 acres, spend 142-ish acres of land to grow wheat and corn, and about 14.3 acres to grow soybeans, and he should not grow any oats, because if we actually go and look at the table, which we will not, the oats actually has the worst yield and price overall, so that's why he should never do it. And as a result, his expected total return would be that amount. Fun fact, Bill only has to work less than a Tesla employee, and he still earns more than them. So listen, if there's anything you take away from this, don't work for Tesla. Anyway, because we have more questions to answer, we're going to go right into it. So this is the sensitivity report, because that's what we're going to use for the questions. So question 1, if the price of oats remain at the same as it is now, how much must the yield increase before the oats should be planted? So this is basically the same as how much can we change or increase the coefficient so that the solution changes. And for this, we're basically finding so 444 is the reduced cost, and then we just want to increase the expected return such that, or the difference in expected return. So based on the objective function, we basically solve that equation, and we're going to end up with the yield must increase by around 306 bushels per acre before it should be considered. The same thing for this problem. If the yield remains at that amount, then we basically solve the same equation as last time. We just change a little bit of the numbers. And yeah, the same. The price must increase by about 2.56 bucks per bushel. And the next thing is, if there were no constraint for the minimum product of corn, how would it affect production and profit? So if we take a look at the sensitivity analysis report, the allowable increase for minimum corn yield is negative infinity. So it means that we can decrease it by any amount and the solution will still not change. So it basically means that we can throw that constraint away and the corn will stay. And the reason for that, well, it's corn. It's a beautiful thing. Anyway, the last problem is, should Bill rent an adjacent 40-acre parcel from La Mancha Realty for the season for $2,000? So this is basically changing. So in order to solve this, we have to change the farm size constraint because the allowable increase is about 18 acres, but we're trying to find if 40 acres is worth it or not. So we have to resolve the problem. And after solving it, we'll see that the expected return or profit will go up by almost 25 grand. And he's only paying $2,000 for it, so he should definitely do it. Apart from that, the 40 acres will make him stronger because he has to spend all that work in the land. So yeah, Bill's strong. Anyway, the next thing, so this is the answer report from the solving. And because we're very nice, we're going to give him some more recommendations. So the first thing is that Bill, maybe he miscalculated something. So as long as the ranges of expenses that he calculated is within these range, then he doesn't have to come back to us, which is always the best case scenario. And the next thing is, what if Bill woke up one day and he decides that he doesn't care about minimum production anymore? He just wants to make money. So for this, Bill wants to maximize his returns no matter what. He's going to not throwaways. He doesn't want to come back to us. He doesn't like us very much. But anyway, so the minimum wheat production constraint has a negative shadow cost. So what we can do is we can decrease the minimum yield requirement by about that amount, and that will increase his expected profit by almost $2,000. The next thing is that because in the start, Bill doesn't want to pay for water, but now Bill is willing to pay for water, And because the shadow price for water budget constraint is about $3, and the allowable increase is about 28 acres feet, it means that Bill can make a little bit more profit if he wants to, maybe like a couple of dollars per acre, given that the water bill is less than $3 per acre. And the last thing is, let's say that Bill, not only that he's greedy, stingy, he's also lazy. He doesn't want to work in the extra 40 acres of land, but maybe up to half. So we're going to say that, let's say La Mancha Realty allows for partial, as long as it's in full acres, rental of the 40-acre parcel of land, and the rental price is now $555 per acre instead of the original 50, because the owner is Thai and they want to laugh in Bill's face. But so the original price is from the $2,000 for 40 acres, so it would be about $50 per acre. And the question is, should Bill do it? And the answer for that is yes, because the shadow price is $672, and the allowable increase is about 18 acres. So why not? He can still get around almost $120 increase in returns per acre, so he should definitely do it, given that he wants to work in that extra plot of land. And that would be it for my presentation. Any question? I'm gonna take this off now. This is